Hello everyone, welcome back to GeoMicros. In today's video I'm going to show you how you can compute for your accuracy assessment. So accuracy assessment is simple, means you are verifying the accuracy of your classification. So after calculating for your line use line cover change and then your change detection, the next step you need to do is you need to compute for your accuracy assessment to verify the accuracy of your classification. So it's very simple and then straightforward. So the first thing you need to do is you have to locate your layer. So this and then when you are creating a process, you have to create it on the original layer where you took the classes. So this is the original layer here. You can see I have line use rank over 2024 and then line use rank over 2000. So this one I'm going to perform my accuracy assessment on line use rank over 2000, so that and then it's the same process that we will follow to do the next one, that is 2024. So when you compute your accuracy assessment, you are computing for the various classes you have. So if you are doing accuracy assessment for 3 classes, and let's say you have class of 2000, class of 2010, and a class of 2024, you have to compute accuracy assessment for each of them. So this one, you are computing accuracy assessment for line use rank over 2000. So the first thing you need to do is you have to right click on the layer, and then you open your attribute table. And then when you open your attribute table, you have to verify if you have class value here. So this is what we are going to use to create our accuracy assessment points. You have to verify this class value here. So after verifying, you close your attribute table, then you go to your geoprocessing tool or your search bar here. Then you locate your spatial analyst tool. So I have my spatial analyst tool here. Then you click on the plus button here, then you move to your segmentation classification. So when you open, you click on the drop down or the plus button before spatial analyst tool, you can locate segmentation classification, and then you click on the plus button before segmentation classification, where you will find create accuracy assessment point. So when you locate create accuracy assessment point, you have to double click on it. Then the dialog box will open for you. You have input raster, output accuracy, and then target field, and the number of random points, and then the sample strategy. So we are going to input our raster here. So that's our line use rank over 2000, and then output accuracy assessment point. So this is where you are going to save your work. So where you want to save the work, you can just input it here. So this, let me just give it a name, accuracy 2000. So let's let me just use this name, accuracy 2000. And then we have our target field. So our target field simply talk about what we are going to use. Is either classified or ground truth. So this one we are just choosing ground truth, but you can leave it a default. As you can see, it's optional. You can leave it as default, or you can change it to ground truth, but this one we are using a ground truth. And then you have number of random points. So the number of random points simply means the number of points that you want to show it on the on your classification. So we can just show a number of points on a classification, so that we can just go and verify it and see if where built up is actually where built up is, that's where we have actually classified that place as built up, or where vegetation is, we have correctly classified that place as vegetation. So we are going to create accuracy assessment point, and then you can use any number of your choice. But since we are I'm making a video, and then I don't want the video to be too long, I will just use a few points. But when you are doing a classification for a project, you have to use a point for 100 or something, so more than 100. So from 100 you can just use that point to classify your classification. So this one I'm just using a 30 points here. And then sampling strategy, that one too, you can leave it as default as stratified random, or you can choose normal random. So then you click, so after setting all your criteria, then you click okay. So as we can see here, let me just increase this point so that we can just view it clearly, and let me make it red so that we can see it clearly. So as we can see, we have our accuracy assessment point here. So you can see where we have the points. So after getting our point, we can just import this point to Google Earth Engine to verify and see if our point actually fall within where we have classified that place. So if we have this point here, then this point represents a built-up, so we have to go and verify if this point actually represent a built-up, and then so we have to verify each of the points. So the simplest way you can use to verify this point is you have to import this point as KML file, then you import it to Google Earth Pro to verify it, since you cannot visit the place, or the place is too big or too far from you. You can just use your Google Earth Engine where you can see the terrain very clearly. So the next thing you need to do is you have to import this point as a KML file. So so when you want to import this point as a KML file, you have to go to your conversion tool. So on your conversion tool, you can see we have to KML. When you click on conversion tool, you can see we have to KML. So then you choose layer to KML, then you click on layer to KML, then you input your accuracy assessment point that you created, then you input your output field, and then the rest. So I'll just come back and do this one, and then I'll show you example of what I did. So the next thing we need to do is we have to right click on our accuracy assessment point, and then check if we have our accuracy assessment point here. Okay, so this is our ground truth data, and then this is our classified. So we are going to verify and see if we have our ground truth here, and then we have our classified here. Okay, so I have this example here where we all can see. Okay, so this is my Google Earth Pro, and then you can see I have a sample here. So this is the data, and then I have a sample here. So when you import the layer as a KML, you can just double click on it. It will take you to Google Earth Pro, so it will be very easy for you to do it. So this is a sample of work that I did. So you can see I have all the points here. So this one I can just zoom in. Okay, so this one I can just zoom in and then verify the point and see if where I have classified the point, that's where it's actually for. So that is how you verify your accuracy assessment point. Yeah, so let's go back to our classification. Okay, so the next thing we have to do is we have to make sure that our classification fall within what we are doing. So the next thing we are doing is we have to open our attribute table, and then make sure all this negative one here matches with the ground truth data. So we are going to match all this one with the ground truth data, and then which the one that does not match, we have to indicate it. So you have to right click on the layer, you go to edit future, and then you start editing. So on your editing tab, you just click on your classified, and then you have to make here this one matches this one. So where it doesn't match, then you put the number that was there. So let me just run example for you. So here we have 5 here, so we are going to type our 5, then you move to the next thing, then the next thing have 5, and the next thing have 5, and then 5, and then 4, then 5. So as you can see here, we have 4 here, but imagine we want to Google Earth Pro to verify, and then where we have 4, and then you see 4 is our agricultural land, and then we verify here, and then we see that here is not actual agricultural land, so we misclassify this place as agricultural land, but actually on the ground it's not agricultural land. So, and let's say that place is a water body, so if it's a water body and then we misclassify it as agriculture, you have to put one there because one represents water body. Then we put our one here, and then we do the rest. So you just match it with the ground truth. You match the classified one with the ground truth, and then where it doesn't match, you put what is supposed to be there. So you have to do it accordingly. So make sure all the numbers matches, you don't miss any a number here. And so let's assume this one was 4, but we misclassify as 2, so we just type our 4 there, then type our 3 here. Alright, so this is how you compute your accuracy assessments. Alright, so as you can see, we are done. Okay, have one here. Alright, so after classified all your values to match with the ground truth, you just save your edits, and then the next step is you have to stop edits. Alright, so now we have saved our edit and then stop our edit. So the next step we are going to do is we are going to compute. We are going to compute it. So to compute it, you go to the same place, your spatial analysis tool. On your spatial analysis, you go to segmentation classification. So on your segmentation classification, you choose compute confusion matrix. So we are going to compute our confusion matrix. So on our confusion matrix, this is accuracy assessment. So the input class is our accuracy assessment, and then our output is what we want to. The name that you prefer to save your accuracy assessment. Okay, so let's assume this is our accuracy assessment, and then after creating your inputs and the output, then you just have to click on OK. Alright, so now we have successfully computed our confusion matrix here. So let's open it and see the results. Alright, so as we can see, we have our classes here. So here is where we are going to type our classes. So as you can see, 1 represent water body, 2 represent built-up, 3 represent barren land, and then 4 is agricultural land, and then 5 is our vegetation. So we have our Kappa, our producer accuracy here, which have 89, and then we have our Kappa statistic. So this is our final Kappa statistic, which we have accuracy of 93%. So you can see our classification was accurate. So this is simplest way you can compute your accuracy assessment using GIS, ArcMap, and then Google Earth Pro So thank you very much for your attention, and then I hope this video was helpful. So please don't forget to subscribe, like, share, and then leave a comment. Thank you.